In this video, we're going to look at other ways complex numbers can be written. Usually complex numbers are written with a real part and an imaginary part. For this example, -5 is our real part and 5√3 is our imaginary part. A modulus is the absolute value of the number. In order to get the absolute value, we're going to do Pythagorean theorems. For this problem, we end up with 10 for our modulus. Next, we want to determine at what angle is that number coming off of the real axis. We can use tan inverse to get what's called a reference angle, and understanding that we get a -π/3, we want to add that to pi, which would give us an angle of 2π/3. So we can write this, instead of having it broken up into the real and the imaginary part, we want to write this with the modulus and the angle of that point. Cosine corresponds to the real number, while sine corresponds to the imaginary number. Euler's formula states that e to the I theta is equivalent to cosine theta plus I sine theta. So I'm going to substitute Euler's formula into what I have earlier, and so this point can also be written as 10e to the power of I times 2π/3. In this video, I'm just showing 3 different ways to write the same point, so you're more familiar with the notation that can be used for complex numbers in polar form.